We are recording, and our first presenter will be Navigating the Future DOT Data Management with Brian, pardon me if I pronounce your name wrong, Soliday and Kevin Sigwart, One Spatial Incorporated. I'll hand it off to Brian and Kevin.
Hey, Brian, I think you're muted.
I'm unable to hear Brian.
Yeah, I don't hear Brian either. Brian, are you there?
Yeah.
Oh, there we go. Okay, now we hear you.
Right. I had a headset on, but it didn't work. Huh. Interesting. Sorry about that. All right. Well, so we'll start all over. So, good morning. My name is Brian Soliday, and I manage sales in the Rocky Mountain region for One Spatial, and I'm based here in Frederick, Colorado. I'm joined today by Kevin Sigwart. Kevin is One Spatial's Chief Operating Officer, and Kevin is based in our U.S. headquarters office in Vienna, Virginia. I want to thank everyone for joining us to talk about challenges with geospatial data. We'd also like to thank GISCO and YGO for organizing the summer series here in Elevation Geospatial, and happy that we were able to sponsor this virtual conference event. You know, I'm sure we would all rather be doing this in Steamboat or Sheridan, but hopefully next year we'll all be together face to face. This morning, we'd like to focus on some work we've been doing with a variety of transportation-focused organizations. We're helping them navigate how they handle the constant changes to the data coming in from the various sources and dealing with requirements on that data, improving those management processes. For those of you who aren't familiar with us, One Spatial Inc. is a US company that's wholly owned subsidiary of One Spatial Group out of Cambridge in the UK. The organization began its life over 50 years ago at Cambridge Labs at Cambridge University, and Cambridge still serves as our organization's worldwide HQ. Our US headquarters, as I mentioned, is located in Vienna, Virginia, but we have satellite offices in California, Colorado, Texas, Georgia, and Pennsylvania. Additionally, as you can see on the map, there are One Spatial offices around the world. They're all providing local support and technology implementation for our growing global customer list. We have significant experience across a number of industries, including federal, state, and local government, transportation and infrastructure, utilities, primarily electrical distribution and water, and facility management. One of the keys to the success is a solid technology partnering approach. The One Spatial team on a global level has significant experience in ancillary technologies that are key to our joint success, and several of those key partners were listed on that previous slide. At the core, thank you. At its core, One Spatial focuses on data management solutions to improve the data quality of large, complex systems. We use validation, integration, automation, and our rules-based approach to build strong data infrastructures, leading to better outcomes and making your data smarter. So, One Spatial started doing work in the US about 7 years ago with our first customer, the US Census Bureau. Since then, we've expanded to nearly 50 clients in all of our key segments that I previously had mentioned. Some of the projects with these customers are supporting them with our rules-based approach to conflate, validate, and integrate their data. And this data could be focused on addresses, next-gen 911, transportation data, which we're going to focus on today, utilities, as well as spatial data infrastructure projects. As you can see, we have a number of different state DOTs as customers, including California, Arizona, Kansas, Alabama, Rhode Island, Massachusetts, Pennsylvania, West Virginia. So a pretty solid list of DOTs. We also work at the federal level with Federal Highways Administration, FHWA, to do a number of activities such as data validation, change detection, and conflation for the performance monitoring, for the highway performance monitoring system, or what's known as HPMS. As we are both, as we're data agnostic, we're also helping Caltrans with non-spatial data validation in the use case of supporting them on their transportation asset management systems, like their TAMS project for asset management data governance. We'll talk a little bit about more of that later. Some organizations outside of transportation we have worked with include the state of Nebraska, where we're working with the state on automating their processes for taking data from CAMA or computer-aided mass appraisal systems, validating the incoming data and integrating it, their back end with their GIS. We help organizations such as the state of Michigan and Arizona DOT on their spatial data infrastructures, building automated workflows to ingest the updated data by first validating the data that's coming in, then performing a change detection to find the deltas, and then integrating those changes into their source data sets to maintain proper metadata. Lastly, we're working with organizations to help with facility management. So on the right-hand side, you see Google. So organizations like Google's Real Estate Worldwide Services Group are leveraging OneSpatial's tools and services to implement validation of their CAD drawings to assist in easy ingestion into their asset management system, which is IBM Tririga. We've also implemented validation workflows to validate that Tririga database directly. One of our first customers in the US was Arizona DOT, or ADOT. OneSpatial started working with ADOT and helping them enhance their data supply chain and assisting them in automating procedures to ensure that the data was going to meet their requirements and help them with developing standard processes like change detection. So ADOT had 14 different counties that were submitting updates to them on over 144,000 miles of roads throughout the state. What ADOT wanted to do was automate that process. So when they receive the data, the first thing that happens now is that they run it through a standardized QA/QC process to make sure it meets the state's requirements. If it does not, then they share back with the original data submission entities where specific issues are identified within their supplied data. Once the data passes ADOT's QA/QC process, it then proceeds into an automated change detection process to determine what is different about the current submittal versus the current road network that exists in the ADOT database. So the system provides what we call proposals on how to deal with those changes, such as, is it an addition? Is it a deletion? Is it a geometric reshape of that current feature? Is it an attribution change? Or is it a variety or conglomeration of those issues? OneSpatial's One Integrate system is then utilized to help update the data by a review of those proposals and then acceptance or denial by an ADOT analyst. If denied, the proposal then is submitted for further review to determine whether or not what the system is determined to do is correct. So they actually make that last call before they accept it. Okay. Another transportation customer that joined us a couple of years ago is the California Department of Transportation, or Caltrans. So our joint effort with Caltrans is designed to help them validate their asset management planning system. The current system consists of a variety of different databases, and each one of those houses one part of their asset management system. So, you know, maybe one has bridges in it, and one has pavement in it, and the other has their culverts in it. Caltrans had planned on releasing an RFP to implement a more cohesive system across the board, but first what they wanted to do was understand what is the current status of each one of those systems and databases. How complete is it? How accurate are they? And also, when they perform validations between the different databases, are they in alignment? They needed some help to determine that. So I'm going to pass it over to Kevin, and he can talk a little bit more about this and then jump into actual some product demonstration. So Kevin, it's yours.
All right, thank you, Brian. Brian, you can hear me, right?
Yes.
Okay, just making sure. All right, thank you, Brian. Yeah, so Brian mentioned that some of the work that we're doing at Caltrans on this on helping them with doing some data validations and so forth for their in lieu of and as part of building out their transportation asset management planning system. So just to give you an idea of like the sheer magnitude of the amount of work that Caltrans does, is one of their programs is called SHOP, which is a fix it first program. I mean, obviously trying to keep their assets up to date, well serviced. Well, this project had a budget of $17.4 billion over 4 years. And so if you can make small little adjustments to the way that you manage your projects, it could have huge savings. So what this system is going to do is it's going to bring in all these different assets and then do project planning across those assets. So if you need to service a set of pavement and it happens to be at an intersection where you have some street lights that need to be updated, you can close the road down at one point, update the pavement, fix the lighting, and then not have to make multiple visits to that particular location. And this is the case for any different assets. There's always different projects that could be strung together in order to gain efficiencies. Now, if you are going to do that type of analysis to determine what assets have needs and need to be actually addressed, you got to get all that information into a system in order to perform those validations, in order to perform those the modeling. As I'm sure you can imagine, trying to integrate these data sources when every one of these asset systems are managed by different departments and using different technology. So there are cases where the pavement data is being managed in an LRS-based system. The bridge data may be managed in a GIS-based system. So integrating these become even more challenging. So Caltrans wanted to get, well, one, before we get there, let's see here. So, if you're trying to do one of these integration projects, you can run into some significant hurdles. And one of the stats that I like to show is that 88% of data integration projects either fail or significantly run over budget. And mainly this is due to poor data quality. So Caltrans wanted to get ahead of this. And what they wanted to do was they wanted to implement they wanted to perform some sort of assessment of these systems. So they contracted with Gartner and One Spatial, that's us, to assess these asset systems. This included building an information architecture, but also performing a data quality or building a data quality management plan across all their different core assets. This included validating the individual systems and and how they are related across different assets. So what our role was is we facilitated business rule workshops with the different subject matter experts for all the different asset systems. We built out validation rules in our One Integrate product to perform the validations. And then we put that information into a data quality management plan that can be used by the RFP responders to this implementation of this TAM system in order to understand what kind of challenges they may come about. And then actually beyond that is that this DQMP is actually being used by their data governance group now to actually start implementing policies so that the quality of their entire system is going to be more in line. So with that, I wanted to highlight some of the types of validation checks that we're doing on these cross-asset validations. And to do that, we're going to leverage actually some Michigan data to do so. So we're going to demonstrate running our different One Integrate, One Data Gateway products against some validation checks that are very similar to the stuff that we're doing at Caltrans. So with that, let me first get us all up to speed and understanding what type of data we're going to be looking at. So what you'll see here is a mapping application. This is we're using ArcGIS Pro in this case, but our engine doesn't require any sort of specific technology. You can use whatever GIS application you want to use to run to view the results. So what you'll see here is we have some data in Michigan, and I'm going to just zoom in real quick, and we have some road center lines and we have some culverts. So the first set of validation checks that we're going to run on our data set is to validate our culverts. One, making sure attribution is populated correctly. Do we have a route information? If we know what the shape is circular, then the height and the width of the culvert must be the same. If it's crossing over a road center line, the route information must be the same between these two different data sets. So these are all the types of validation checks we are going to do. So to do that, we are going to validate the culvert data. So I'm going to go flip over to my One Data Gateway product, which is an application that can be hosted either internally in your own network, or it can also be hosted as a cloud-based solution. So if I was wanted to validate my culvert data, I could come in here and I could select which set of data or which project I want to validate against. And you'll notice here there's a lot of different projects we have in this application. But in this case, we are going to focus on the Michigan one. So I'm going to go ahead and select that. We're going to start a new submission, and I'm going to grab my data set, and I'm going to drag and drop this into the application. Brian was mentioning before the work that we're doing at Arizona, and this is a very similar process where the counties would upload data, and then they want to go through and they want to validate the data to make sure that it's meeting the business needs. So this is just another example where you can collect data from data providers and validate it to make sure it's meeting your business needs. But typically when you're doing this any sort of data roll-up or collecting data from different organizations, they have a tendency to manage their data in their own schemas. It makes sense. They have their own reasons for doing so, their own business systems and so forth. So what we allow them to do in the application is to actually do schema mapping to determine, what the source and what the target classes are and the attribution, and it will tell you whether or not everything is mapped correctly. We can also determine which ones we want to select. So we have a predefined mapping, or we could create our own mapping also. Once we save that mapping, we can go ahead and just run the validation checks against the data. So what we're going to do is we're going to first bring in some road data. Now you notice I only uploaded the culvert data. So the road data is existing in an enterprise-based system because we're going to use the culvert data to validate against the road data. So we can pull in data from a variety of different sources. We're not just limited to validating one geo database. We can validate a GIS database. We can validate some sort of non-spatial database. We can bring them together, cross-validate. In this case, we're looking at culvert data and road centerline data. We're going to bring it into our engine, and we're going to validate it against a set of pre-configured validation rules. And I'll get to shortly about how you can configure your own business rules. So it's going to bring those data sets in, and then we're going to run it against two sets of validation checks in this case. The first set of validation checks are what we call our essential geometry checks. They check for typical geometric issues that we find in all GIS data, things like duplicate features, duplicate vertices, kickbacks, spikes, things that just occur when you're doing your GIS editing. Notice that we're getting reporting back about the quality of the data as it's running through. So if I open up this drop down, we could see for each of the rules that we ran against, this is what our conformance levels are. And then we're going to also run it against some culvert data, more culvert specific validation checks, making sure they're not too short, making sure they're crossing over the road center line, making sure that the width and the height are the same, making sure that the roads are crossing over, if the culvert is crossing over a road has the same name, things like that. And we're also getting those conformance percentages in this case too. What you'll also notice is that we brought in a fair amount of data. So we brought in 6,000 road center lines. We brought in about 3,000 culverts, and we ran all these validation checks in probably about a minute and a half. So this just gives you an idea of the scalability of this validation engine. When we validate Caltrans' entire route network of some million records, we were able to validate it against about 16 validation checks, and it took only about 14 hours to run it through that. So that gives you an idea of the scalability. This is why a lot of large national government agencies and even state agencies are using our software. Anyway that has lots of data and complex challenges, which could even go all the way down to the county, like in LA County, we can help them with those challenges. So I'm going to go ahead and hit continue. So I can see in the interface itself what my results are from the validation checks. I can download a report to see what the results are. But beyond that, what is more important, what we really want to do is we want to empower the users to be able to go through and correct their data set. Now, to do so, you got to do more than just providing them a report and telling them what's wrong with the data. You got to tell them where the issues are. So what you can do is you can download that report as a shapefile or a file geodatabase, depending on what your system is, and then you can load that into your application in order to zoom to where exactly those issues are. So it really streamlines the process of doing the data cleanup. But beyond that, and we'll get to those results in a second, is that we're also getting a dashboard of all of the quality of the data as data is being submitted over time. So we can see which rules are failing the most, how often data is being submitted. We can look at how the quality of the data is trending over time. All those things we can look for. So if we go back over to my application, let's take a look at some of the issues that we flagged. So we go back out to the state level. I'm going to turn on the data set that I downloaded and brought it into my map, and we could see where all of my issues are. If we zoom to some of those examples, so let's zoom to the duplicate feature issue. I'm going to go ahead and select this feature here. And we can see, yes, we're flagging that there's a duplicate feature. And here I have 2 culverts, same geometry, same attribution. So we can identify where we had those duplicate geometries. If we have another example here where we have a kickback. Notice how it's kicking back on itself, but we're not just telling you there's an issue with the feature, we're telling you where that issue is occurring. So this can help you drive you to that issue to auto correct it. You can imagine if you had a pipeline or a road center line that extended miles upon miles, if you have this little kink in the network, being able to know where that issue is at is very important when you're trying to do that data cleanup. Here's an example where we have a culvert, and if I look at the attribution, it's of type circular, but we notice that the height and the width are offset. So we not only are we doing spatial validation checks, we're also doing attribution validation checks. If it's a circular culvert, it must have this relationship. And then we can also do validation checks. Looking at, in this case, we're looking at the spatial validation check. We're making sure that the culverts are crossing over a road center line. If it's that type of culvert, in this case, these are not, so we're flagging those. And then lastly, here we have an example where we have a culvert crossing over a road, but the naming convention, the naming is not the same. So this one says it's US 10, Waverly Road. It's not a match. We're flagging that. If we look at this culvert here, this one is of US 10. It's crossing over US 10. It's not being flagged. And we can also set tolerances in here. So we're actually ignoring the dash so that we can find those matching. So we can really fine tune these rules to be very specific to the issue that is there. But beyond that, we can do more than just doing validation. We can also do enhancement. We can clean the data up through the engine itself. So for example, if I'm not going to run it live. Well, actually, let's go run it live and then we'll come back. So if we come back over to my One Integrate application, what's going on behind the scenes is it's pulling data in, it's running a series of validation checks, giving you the conformance ratios, but then we can also run what we call cleanup actions. So I'm going to go ahead and just hit play, and it's going to go through these cleanup actions, and it's going to do those cleanups, and then we can rerun the validation checks to see, well, is doing these automated cleanup actually cleaning the data up. So when this finishes, we can bring this cleaned up data set back into the map, and we can look at what the results look like. So if we come over here and go to where we had that duplicate feature, let me turn off the old culvert data set, and I select this particular one here. We're going to see that we now only have one culvert. It removed that duplicate feature. If we come over to where we had that kickback, notice how where we had the kickback originally, we cleaned that up. We also, where we had the culverts that were not crossing over, we base off of a certain tolerance. If there's another culvert that's across of a particular road center line and these have the same route information, we can connect those together. So originally it looked something like this. And then we were able to, build out, connect those features together. So that's looking at one individual asset. But what happens if we start looking at assets across the entire enterprise, more than just comparing culverts to road center line? Maybe we want to look at the bridge data, the pavement data, and the culvert data all on one particular road center line. So if we come over here to my cross asset validation check, you'll see here that we have some bridge data, we have some pavement condition, culvert, and road center line. Now, I'm not going to run this live. I could run it live, but just for the sake of time, I'm just going to show you where the issues are and just show you some of the validation checks that we performed on the data set. So for example, if I come over here and I look at this example here, we are saying that if there's a bridge here, where we have a bridge, we have a route ID, we have an LRS value. We're saying that the road center line must have a value within that LRS range within a certain tolerance. So if I look here, none of these values for this route are within that LRS range. The one that is in the LRS range is located right here. So we could see that this one is, but it's outside that tolerance, which is why we're being flagged. We're using a 20-foot tolerance. This is over 60 feet away. So we could either tweak the tolerance, or maybe the bridge is actually supposed to be located over here and not over here. If we come over here to another example, we're looking at not just the bridge data, but we're comparing the bridge data to the pavement data. and where we should not be reporting pavement condition on a particular where there's a bridge at. So if I select these features here I have my bridge. It's saying that at this LRS value, there should be a bridge. If I look at my pavement condition, I'm reporting pavement at that location. There should be a gap here, and notice that there's not, which is why we're flagging that as a nonconformance. Now, for example, if I come over here to this example here, and we zoom in, we'll notice that there's actually, where there's a bridge, there should be a gap in the pavement reporting. So this is why this one here is not being flagged as a nonconformance. Here's another example where we have a bridge. It's being flagged. If I select this particular bridge here, we can see, yes, we have a bridge. What's interesting is that in this area, there's pavement conditions not located because we're not in that range of values, and neither is a road center line. But if I zoom down, we're going to find actually that there is a gap in the pavement condition right here at this location. And what's happening, and if I look at this particular segment, road segment, that's actually within the LRS range of values. So what's happening is that this bridge should actually be located down here and not all the way up here. So by performing this cross-asset validation checks, we can really see these issues. We can really see where there's inconsistencies between the different data sets. All right, so let's come back over to my slide deck. I know I went through that really quickly. I just wanted to highlight two other quick use cases. Another case is where we're working with DOTs is with validating their crash data, bringing in data sets from multiple different, conflating information over, like the road name information, comparing that, the accident report information to those networks, and then doing cross-validation checks against those data sets. And then lastly, for federal highways, we're doing work with HPMS. So validating, we're updating the validation rules for the new HPMS 9.0 to do more topological type validation checks. And beyond just doing these validation checks for federal highways, we've also worked with a number of DOTs in implementing these HPMS validation checks running on site at their locations. So I really went through that quick, but we have 30 minutes. So we have 3 minutes to go for questions. Brian, did anybody pose any questions for us?
The one that I have was a question about the rules, and can, in the rules-based system, are the rules built by OneSpatial, or can the customer build their own rules?
Oh, great question. And I mentioned that I was going to show the rule configuration and I didn't get to it. So yes, either you can write your own business rules, or OneSpatial can help write rules for you. Typically, we have, not typically, we have two trainings. We do an intro training and an advanced training on the product to teach you how to write your own rules. So the idea is to get you self-sufficient so that you can write your own rules. But there are cases where we may either have a set of rules that we've already developed for different DOTs or other, local governments, state governments, that we provide as a set of starter rules. So we have like the HPMS validation checks. We have like road centerline validation checks. We have addressing type validation checks, next generation 911 NINA validation checks. So all those will be like, we can provide to you as a set of starter rules, and then we'll train you on how to write your own, or you can even contract with OneSpatial to write all the rules for you, or a subset.
All right.
Thank you, Brian.
And is there any limit to the amount of data that can be ingested into the system?
No. So I surely mentioned the speed and the way that we're processing through the data, but and I didn't really talk about too much of the actual underlying engine. So the reason we can process through this much data and this quantity of data is that it operates on a object-oriented disk cache. So it indexes the individual geometries and the attribution so it can perform quick feature-to-feature transactions. So this enables scalability too. So we work with national government agencies that have extremely large data sets. I know I mentioned Caltrans as an example. Just the other day, we validated some utility data, and we brought in 15 million records, and we validated it in, I think it took about 12 hours to run it through about 20 or 30 validation checks. So just to give you the sheer magnitude of the amount of data that we can process through and validate in a very timely manner.
Okay. All right. I think we're about done. If you could go just to the next slide real quick, I can close it out. So OneSpatial, Kevin and I want to thank you for your participation in the participation and your overall support for the Elevation Geospatial Summer Series. If you're not a member of GISCO or YGO, you really should be. I mean, it's $2 a month is a pretty small investment to be a part of your state's professional GIS organization. So this is just a suggestion to be a part of that. So if you have any questions, if you want to please reach out directly to myself or Kevin if you have any questions, and we can schedule a follow-up and give you a deeper dive on the technology. So we look forward to working with you in that capacity. Thank you for your time this morning.
Thank you, everybody.
Thank you, Brian and Kevin. That was great. Next up, we are going to hear from Scott Trapolino with NG9-1-1 Collaboration, Cooperation, and Collection.
Let's see if this works. Can you hear me all right?
And thank you.
All right. Can you see the screen? And which screen can you see? Resume slideshow. Can you see it? It's not actually allowing me to. Here we go. Can everybody hear me? Hello?
Yeah, you're live.
Okay, I was just making sure because I have 6 monitors and it's I've been having some glitches this morning. Can you see the NG9-1-1 collaboration cooperation? Can you see the
Yes.
the first slide? Okay, good. It's sharing then. Well, my name is Scott Trapolino. I'll give you a little bit of an introduction. I am actually captain on a volunteer fire department. See if my video will share here. There we go. How's everybody doing? All right. I'm captain on a volunteer. We're half volunteer, half paid fire department. I've been a firefighter for about 15 years, and I've been a GIS professional for about 15 years. So I kind of started both of them, both careers at the same time, and it's kind of given me a really good perspective on sharing information and collaborating with people from next gen 911 moving forward. You know, I've got the first responder experience. I've actually worked in dispatch as well as played with GIS data. So I'm going to give you just a breakdown of kind of how we're working to collaborate with the state of Mississippi right now. And I'm actually working with several other states as well and showing them what we're doing. It's kind of like a grassroots movement. Today, I'm just going to talk about, I know I have a short amount of time, so I'm going to skip over a lot of the key terminology because I spoke with my counterpart that's going to be presenting afterwards with DataMark, and they're going to talk about a lot of the terminology and the data and how that gets, how that actually gets put together for a next gen 911 system. So we're going to focus more on field data collection methodology and education, because as you know, we know what points, lines, and polygons are, but dispatchers don't necessarily do, first responders don't do. So I'm going to tell you some of the things that I've done to break down those communication barriers between them as well as GIS professionals to kind of open up the doors to share data back and forth. So first off, I'll start this out with the National Telecommunication and Information Administration put out a Next Gen 911 grant. I don't believe Wyoming got any of the money, but I know Colorado got about $2.2 million, I believe. And this is to be spent over the next 3 to 4 years to help implement Next Gen 911. And if you don't already know, Next Gen 911 essentially is 85–90% GIS, which is awesome. Let's go ahead and talk about, so your basic 911 in the past has come through telecommunication lines, through copper wires, through your landlines, but who has a landline anymore? I mean, I don't have I just got rid of my mom's landline for her, and it was like pulling teeth. Of course, she's 75 and she wanted to hang on to it because that's been her number for years. But she also has a cell phone and never touches her actual phone. So in NextGen 9-1-1, I'm sure Datamark's going to touch on this more than I would, but we have these things called EZNets, which are IP-based software services and servers that actually process the data, give a geolocation based on the geospatial data and the incoming call. So this terminology, I'm going to kind of skip through these because I'm sure that they're going to touch on it. Have any of you ever seen this before? It's pretty much universal. This is an MSAG. This is one of the data sets that you have to have to, it's kind of the, I guess it's the old school system right here. This is where the call comes in. You have a street name and you have a high and low address range. And if for some reason your call comes in and you live on First Street and you live at 321 First Street, it will throw an error because it doesn't meet that high and low address range. Well, in NextGen 9-1-1, the data is actually going to come in and be processed through the point addresses, the street center lines, the emergency areas. So here's some more terminology, and I'm sure they're gonna, Datamark's gonna touch on this a little bit more. Let's skip through this. So anybody that's ever done anything for 911, right? I'm thinking as a GIS professional and a 911 professional, you're looking at this map that I built, and it's essentially, it's a map of DeSoto County. This is my fire district right here. We have 2 fire departments. And I wanted to break it down by run area. So I said, well, why would I need 3 layers? You know, a layer for fire, a layer for EMS, a layer for law enforcement. So I put them all into one layer. And then I just broke it down by who would respond throughout the entire county to each one of these. And you don't see it, but these are broken down by sub-districts underneath, all into one layer. Well, come to find out, I thought I was doing a great thing. With NextGen 9-1-1, it all has to be broken down into individual layers. So GIS layers, we're gonna go ahead and go through these real quick. Strongly recommended. So I didn't get a chance to update the PowerPoint after I spoke with Datamark last night because it was late last night. So I told them I'd kind of skip over some of the information so we're not double dipping here. But the state of Mississippi has finally got something together for our addressing standard, and it's with our coordinating council right now. They are going through the process of approving it and updating it, and it's something that's definitely needed. And what I was surprised with is that many states don't have standards. It was very limited when I started reaching out to states on what kind of standards they had and what they were actually adhering to. And most of them go back to the NENA standard. So this is one thing, if you want to break down barriers of communication between your dispatchers, I don't know how many of you are local government or work with data like this. So point addresses, lines, and polygons. I went in and actually said, guys, I have these points, line, and polygons, or these point addresses, street center lines, and emergency service boundaries, and sat down with my dispatchers and all right, why do we need this? You know, we've got a paper map on the wall. We can go up there and look at it. We've got Google Maps on our computer, which is not always right. But I had to break down what GIS was to them and how it actually comes together. So I kind of put together some just basic slides, went in and showed them, all right, this is a point address. This is a street center line. And then I would click on the street center line and I would show them the attribute information built on the back end to where the address ranges to the left and the right of the streets, because you would be surprised. I would assume anybody that does their job would really dig in and find out exactly what information and data is what it took to build that. But we take that for granted as GIS professionals. As GIS professionals, data is kind of our bread and butter. It's our key, you know, it's what puts everything together for us. So I broke this down and actually started showing the dispatchers how this information was put together and why it was put together. And all of a sudden light bulbs started coming on. They were like, oh, this is how the point address comes in and finds out and tells us whether it's a club or a classroom or a substation or a prison. And, and then I turned on, we had all of our addresses linked to our to our commercial structures. And I went ahead and linked that and showed them how, when they type in Walmart, how these different databases play a role in the information, and why it's so important when they find an error in the data set to give that information back to the GIS professionals in their organization, because that's going to play a role. They're not going to have that error again. Whereas before they were just dismissing it. So here we go, data validation. I'll let Data Mark talk about that. I'll give you a little bit of our grassroots movement. So what we're doing right now, in the state of Mississippi, we had an issue. We didn't have any, their standards are not set between counties and municipalities. And it's the same in Colorado, I noticed, as I've gone out and actually spoken with several people. I'm not sure, but I'm sure it's probably the same in Wyoming as well. But we found out that not everybody, you know, some roads would start at 100, some roads would start at 1. And we were like, we came together, Mississippi 811 and the coordinating council and the GIS professionals in the state, our organization came together and said, all right, what can we do? This was about 4 years ago. What can we do where do we need to start, essentially? And so our starting point was, we need to go out and collect what's out there right now, because we can't fix what we don't know where the errors are. So Mississippi 811 took a leap of faith and said, we are going to work with our local individuals, because we need to know to be able to protect not only our utility workers, but to protect the citizens' critical infrastructure. So they took a leap and actually sat back and said, we need accurate GIS data. And they came in and did a pilot study. And then now we've collected multiple counties. I'll actually have a slide that shows you how many counties we've collected so far. But we've gone out and we will get an individual, an EMA director, an E911 coordinator, or a fire chief or a police chief. And we'll say, hey guys, do you want this cool GIS data? And we'll show them what we've done from a previous county, and that they want it. They want the point addresses, the street center lines. But to get buy-in from them, we make them give us one of their employees and a vehicle, and we find a GIS professional, whether it's with 811 or a surrounding county, and they volunteer their time, sit in a truck or a car, and they ride every road, collect all of the point addresses. We process that data for them. 811 has 3 GIS professionals that process that data for them, give it back to them, and then we show them how to maintain and update that data and why it's important. So these are some of the counties that we're completed in 2018, 2019. I'm actually going to Covington County this Thursday to finish up their project, and we're working with Smith and Marshall County. These are some of the counties right here that are done so far. And just within the last 3 years, we knocked out these 4 counties, this county, Quitman, Coahoma, and here's Covington. We're doing Covington and Smith right now. So we have approximately 67 PSAPs, or 67 of the 160 or 116 PSAPs done so far for point addressing and street center lines. So field data collection, I don't know how many of you have been doing GIS. I've been doing it for a while. I initially started helping people do 911 mapping with paper maps. Then we moved to GeoPDFs. I dug into Avenza PDF for a while, and then we went to ArcGIS Collector. But the problem we have is we're a really very rural state. If you've noticed, we've only got about 2 million plus residents. And so we have no connectivity in a lot of areas. We don't have cell phone service. So even with Collector being disconnected, it was very slow processing. So what we did was we dug in and found CarryMap, which is Data East. They do XTools Pro. They have this map to where we can export our data out into the map, and we can update it and update it and fix it as we're actually riding the roads. And what has been really, really neat, you working with Mississippi 811, is everybody, you might not have point address data, right? But we did have, they have meter data. And most of our electric co-ops have gone out and actually GPS their meters. Now, whether they did it accurately or not, the point is still there, and it's attached to an address, and it's close enough to the structure where we can move those points and adjust them. And Mississippi 811 has really stepped up and gone out to the electric power associations. So in some of these counties, we get the electric power data for the entire county. We adjust the points. We readjust all the street center lines, and then we ride every road. And Mississippi 811 just made just a data agreement with each one of these electric co-ops that we would share the data back with them. And so through that collaboration and collection, we really kind of opened up doors that we haven't had before. I sat down in a Mexican restaurant and had lunch with an electric co-op, a 911 coordinator, and a county representative. And they had no clue that the county flew new aerial photography every 2 years, and they were just using whatever they could find, the electric co-op was. So that kind of put those hands together. And now when we get new electric power, when there's new meters that are put in, that's kind of a checks and balances against the 911 data, as well as they're sharing their other information back, such as parcel data, imagery, anything that would help the electric co-ops. So here's kind of, when I first put this together, I thought, oh, look, this is cool, you know, collaboration, collection, education. And one of my friends said, well, they don't meet. And so I had to put another slide together. So we're bringing them all together. The current status we have right now in the state of Mississippi, we've taken some of that funding that we've gotten from this grant, and we now have a state 911 authority as well as a 911 coordinator, and address has pretty much been put to the forefront and essential for Next Gen 911, especially with the census that came up this last year. We ran into so many issues because we didn't have accurate point addresses throughout the state. Here we go. So now this is going to kind of close it out, but what we had to do was, we're coming in and we want to train the dispatchers, any GIS professionals they have that are local, as well as the first responders. And what we've done is, how can we put together what we call it's a needs assessment, a next generation 911 needs assessment. And if anybody of you have ever done a needs assessment before, you know, especially with GIS, you've got to look at those 5 key elements. So what we did was we created a questionnaire. We found what GIS data is available for each one of the PSAPs. We asked them what their local budget constraints are. We teach them about Next Gen 911 terminology, and then we find out who their CAD and record management system vendor are and whether they're Next Gen capable or they're going to be Next Gen capable. And we've been kind of processing this data, and as we go county by county, we're sharing this back up to the state level. So eventually we'll have a collection of PSAPs. So these are some of the questions, a collection of what kind of data they're going to process, and where our really pain points are going to be statewide when we try to implement a statewide GIS. So these are some of the questions we asked, and I'm just going to go through these with you and tell you a little bit why they're important. So how many full-time dispatchers are employed? How many part-time dispatchers are employed? We need to know what their manpower is. Are they under, do they need to hire some more people? Administration personnel employed. We asked them for their budget. We also asked them for who is the addressing authority, because when you go into Next Gen 911, somebody has to own that data. Now, whether it's your planning department, your development authority, your 911 authority, you know, and who officially names the roads. In the state of Mississippi, we have a breakdown of communication in a lot of places because we have a road manager, and the road manager is just as powerful as the county administrator or city administrator. And those road managers manage a road registry, right? And that's supposed to be the official road. Well, the problem is sometimes the road registry doesn't match what the street sign says, which doesn't match what the MSAG, which is that original spreadsheet we looked at the beginning, you know, and so whose data is right and correct. And so that's kind of some of the issues that we run into, but without knowing who's in charge of that data, it's hard to maintain it. So what's the most pressing budgetary constraints, communications, what's your communication provider, contact information? Does your PSAP have the capability to receive text to 911 information? a lot of these dispatchers don't even know if they have those capabilities or not. So we've been helping them learn about their system, because it's more than them just going in and answering a call and directing first responders to a place. So hardware, total number of dispatch consoles, what operating system do you have installed on your dispatch console? You'd be surprised how many people are still running XP. Scary. Software vendors, you know, and then we get their date on when they're next gen ready, so that we'll be able to pass that information on to the state. So, and we also, this is probably the most important thing to me, is I love getting somebody's GIS data and looking at it and figuring out how we can help them fix it, seeing what kind of topology errors they have. And when you say topology to people, they think contours. So you got to break that down for them and tell them what that is. But training and education has really been the biggest thing. And I have to give my hats off to Datamark. They've come in multiple times to our state and they've given us educational trainings to where we've been able to bring in not only GIS people, but first responders, as well as EMA directors, people who are, you know, key stakeholders, and then putting everybody's hands together. And you'd be surprised how many times I see the GIS professional in a city or county has never sat down with the EMA director or the 911 coordinator and shared ideas and information to see how they could make first responders' lives a little easier. So that's a huge win in my book through this next gen 911 implementation. So this is something we've been putting on workshops. We try to get people to volunteer their time. So Mississippi 811, Datamark, Everything is Somewhere, Canopy Spatial. We've been coming in and we've been doing free data reviews. We'll look at all the data, see where you're at, kind of give you a thing, and see if we could potentially get some money or some assistance through Mississippi 811 to help them figure it out and get, here we go, and figure out where they are and where they need to be in the long run. So that, I kind of flew through that pretty fast. One thing that I really didn't get to touch on is after we collect all of that data, we process it and actually give it back to the first responders in the county so that the dispatch has the same information that the first responders have. And what that does, it allows for the first responders to then become GIS professionals. So we've trained over 2,300 firefighters and police officers throughout the state using this carry map application with their point addresses, street center lines, and emergency boundaries. And so they'll go out in the field, they see that a hydrant's not in the right place, they can mark it on the map. They see a road name's not correct or a point address has been added without going through the proper channels. They can send all of that information back, whether they be volunteer or paid participants. They send that information back to the 911 coordinator or whoever's coordinating efforts through GIS. And essentially you've got 50 to 100 GIS professionals, semi-quasi GIS professional first responders in the field, going out and helping you update and maintain your data and make sure it's right, because they understand the importance of it. So does anybody have any questions? I know that was a lot in a really, really short amount of time. No questions? Well, I would say I appreciate your time and thank you very much. If you have any questions or concerns or just want to ask me some questions on how you maybe could implement some of this stuff in your state, by all means, give me a call. I don't mind sharing my time.
Thank you so much, Scott. That was a great presentation. Moving on, we will go to the next presentation, which is Next Generation 911. And Next Gen 911 through the lens of a GIS professional with Sarah Rollins at Datamark. Sarah, I'll hand it over to you.
Hello, can you hear me?
We can, thank you.
Okay, great, thank you. Do we want to take a quick break in case people were planning on joining us at the top of the hour?
That's a great idea. Yeah, we can take a break for 4 minutes or so.
Okay, great.
We do have another question for Scott, I believe, if you're still around.
I am. I'm still here.
The question is, what does your road coordinator do when there is a name conflict or duplication?
So so what we do is we look at the different data sets, and 9 times out of 10, I'm going to be completely honest with you, if the road sign says something and the parcel data backs that up, as well as the point address data, that kind of trumps the road registry, even though the road registry is the only legal binding document in the state of Mississippi for road names. So what we'll do is they'll have to amend that at the board, or we could potentially tell them, hey, you're going to have to change the road sign. So it's really, if the MSAG, I try my best to make the MSAG match what's actually out there in the field.
Okay, great. Thanks, Scott.
No problem.
Okay, it's 11 o'clock. Should we get started with Sarah?
Yes, I think that would be great. I just need to share screen.
Okay.
And I might be missing that. I don't see yet.
It should be at the bottom of your screen.
Let's try this again.
I can make you a co-host and maybe that will help.
Interesting. Let's see. I had the chat up and now everything has disappeared. It's always this way, right?
It is, yeah. If you're in full screen.
I just found it. It's this teeny tiny little box all of a sudden.
Okay.
All right, let's see. So there we go. Exit minimize. I don't know how it got minimized. Let me go ahead and see about, I got that going. More participants, chat, Q&A. Where am I missing the screen share?
If you are out of the full screen, it should be at the bottom of your screen, or it could be at the top of your screen in a little window.
I got it now. Thank you. All right. All right. I am technical, really, honestly. Okay. Let's see here. Screen 1. And you should see a presentation slide. Is it working?
It is working. Yep.
Fantastic. Great. Thank you. Thank you for your patience. Hi, my name is Sarah Rollins. I am a public safety GIS expert with Datamark. And as Scott mentioned, we provide education, software, and services for next-gen GIS solutions to local, county, and state-level agencies. And just a little bit about myself. I started working in GIS almost 30 years ago and started working in public safety GIS a little over 4 years ago. My passion for sure is educating people about all things pertaining to GIS, and public safety is such an essential application of GIS. I'd like to say thank you to the Elevations Geospatial Summer Series crew for putting this together, and thank all of you for joining me today to talk about Next Generation 911, GIS, and you. And some of this information might be a bit of a repeat for you if you watched Scott Trapolino's great presentation that happened right before me. And I'm really glad for this opportunity to dovetail my presentation with Scott's. This will give you a chance to really let all of this information sink in. This is also a short presentation, and we'll have time for questions at the end. I do want to start with a couple of polling questions to get us going and to help me know my audience better today. So if we could launch the first polling question, that would be great. All right, so what's your GIS relationship to 911 right now or in the foreseeable future? So I can see we've got some answers rolling in here. We'll just give it another minute. We've got 3 folks responding. And if you can't find the poll, I think if you hover in the bottom of your screen, you'll see something that says polls or polling, and that should open it up for you. All right, we've got six people. Great. So, okay, so for the most part, for those of you who responded, not doing anything with 911, but we do have a few of you who are supporting 911, so that's great. Thank you. All right, let's go to the next question. Oh, do I have to share the results? I guess I have to share the results. All right, so if we could go to the next question, that would be great. All right, so what's your GIS relationship? Oh, this is the same question. We need to move to the next question, please.
Sorry about that.
That's all right. I thought, wait a minute, I think I already read this one out. All right. This is a different one, thanks. All right, so what is your understanding of how GIS is used in 911? So if most of you aren't supporting 911, you might not have heard of anything. So, okay, great. We've got some no ideas coming in, and let's wait for a few more of you to respond so I have an idea of my audience level here. All right, anyone else want to put a vote in? All right, great. I think we could probably end that. So we've got a good smattering. Let me hit the share results button here. So yeah, so we've got some people this is all new to, and that's great. And then we have some folks who have heard of some of these next gen functions. So that's also great. Okay, and then how about the last question, please? All right, last question. MSAG and ALI. Has anybody heard of either of these or works with either of these? Great. All right, excellent. I'll give it another minute for anybody else who wants to answer. Fantastic. All right, how about a few more people? We got 8 out of 14. Any takers? All right, great. Thank you. All right, so again, we've got a nice spread to the audience today. So thank you for doing these polls. It just helps me to know if everything I'm talking about is new or if we've got some people who are familiar with it. So that's great. All right, I'm going to go ahead. I'm going to stop the share results because it looks like I can do that. And let's go ahead and close the poll window. And let's get going on the presentation. All right, so we're going to start off with understanding that when it comes to answering a 911 call and locating a caller, 911 relies on the answers to two very important questions. The first of those is, which PSAP or public safety answering point, and that's actually the call center where the calls go in to be answered by a call taker or dispatcher. So which PSAP does this call need to go to? And quite literally, when someone dials 911, what center, what calling center or PSAP does the call get routed to? And we call that call routing, when you route a call to the call center. And that's a big point of determination, is which center should answer this call. And the second is the caller's location valid? And by that I mean, is it actually locatable on the face of the earth? And once a call taker or dispatcher at the PSAP answers a call, their first concern is, please state the location of your emergency. We need to find you in order to help you. So before the call gets to the PSAP, the big question there is, which PSAP should the 911 system route the call to? And then once it gets to the PSAP, the dispatcher or call taker needs to be able to verify and validate, or geo-validate, sometimes they use that word too, the actual location of the caller. Once these two questions are answered, the 911 personnel can get the right responder to the person in need. In current state 911, which is also known as enhanced or E911, finding the answers to these two questions relies on tabular data. I'm going to do an extremely high-level overview of how call routing works in E911 today. Of course, we'll start with when someone dials 911, the phone number is routed to query the alley. Scott mentioned the alley briefly. Query the alley, which is the automatic location information. It's a tabular database owned by the telephone provider, and the alley houses phone numbers and civic addresses, and these are parsed into address components. A civic address is often the same as a postal address for the structure, but it's not always the same. So for 911 purposes, it's vital that the alley query returns the actual civic address for that location. And the result of that alley query is then sent to query the MSAG, which Scott also briefly showed us. And that's the Master Street Address Guide, another tabular database. And the MSAG is used for emergency purposes. It's typically owned by a state or municipal authority. And the MSAG is intended to contain every street name and each street name's address ranges. So querying against the MSAG helps to validate that the address that was returned from the alley query is real and locatable. And when the MSAG ranges, address ranges are correct for the centerline segments, this effectively provides a database with every possible address. And each of these has an associated ESN, or emergency service number. One thing that the ESN indicates is which PSAP the call should be routed to. So after the MSAG is queried, the call should be on its way to the correct PSAP. Again, this is a very, very, very simplified explanation of this whole process for call routing. The point that I want to make is that a call location, which is a point on the globe with geospatial attributes, all of this is being determined through tabular, non-spatial databases. These databases, they're notorious for having errors and for being out of date, so they don't always return the correct PSAP. This results in calls being misrouted to the wrong PSAP. This delays them in getting to the correct PSAP, and in 911, every second matters. All right, so enter next generation 911. In next gen 911, when a call enters the 911 system, the information from the call will enter the EZInet, and that information will be processed by several functions. And there are two key GIS-based functions that we're going to talk about in just a moment. After these functions do their job, the call will then be transferred. The call will then be transferred to the correct PSAP, and then the normal PSAP business processes can continue, like unit recommendation and dispatch. So anything that would normally happen once a call reaches the PSAP. All right, let's take a look at these two GIS-based functions. The first is the location validation function, or the LVF. And remember that in E911, the address information from the alley is queried against the master street address guide to verify that it is indeed a valid location. In NextGen 911, the LVF serves this function for all intents and purposes. And in the LVF, all the valid locations are pre-verified against the GIS data before the calls are even made. So instead of relying on non-spatial tabular information, the 911 system is now relying on GIS data to verify if the addresses are indeed locatable. This is a huge advantage because typically the GIS data will be managed by someone with local knowledge. This is valuable as opposed to an MSAG that might be managed by a non-local company that oversees MSAGs for dozens of communities. All right, and the other GIS-based function is the ECRF, or Emergency Call Routing Function. This is where things really get exciting for GIS. Remember that in E911, a call is routed to a PSAP, again, based on non-spatial tabular information from the alley and the MSAG. And in NextGen, that's not going to happen. Instead, the ECRF will literally run a point in polygon query on the location of the call to determine which PSAP boundary the call falls into. And then the call will be routed to that PSAP. This is especially important when calls come in from near a PSAP boundary. In E911, calls near boundaries can often be misrouted, especially if it's a cell call and the nearest tower is in the neighboring PSAP. But with the ECRF, since the call is routed based on its actual location and not the location of the tower, we have a much better chance of the call getting routed to the correct PSAP. You might be thinking ahead already, since I know you're all GIS people, that it would be crucial to have all of your boundary layers topologically correct with no gaps or overlaps. And to give you an idea of what this looks like for the ECRF, then consider this. Imagine a call coming in from this location. The call falls in a gap between the blue PSAP and the green PSAP. And since NextGen systems route calls to PSAPs based on the point in polygon query, this call wouldn't be able to route. And the system does have rules and policies built into it to optimize the outcome if a situation like this occurred. But the bottom line is that you can't have any gaps or overlaps in your boundary layers. And that includes your responder boundaries as well as your PSAP boundaries. It's important to note that the 911 authority is responsible for coordinating with local addressing authorities and GIS data providers for the provisioning of address data in a GIS format to the ECRF and LVF. So the primary stakeholder is not the telephone provider anymore. In fact, once NextGen 911 takes over 100% of the calls and E911 systems are no longer being used to route calls, the telephone provider won't be a stakeholder at all because the system won't ever touch the ALI database anymore. So now with NextGen, the prime responsibility for the data used in 911 call routing lies with the organization that makes the most sense, the 911 authority itself. And that doesn't mean that the 911 authority will necessarily be editing and managing the GIS data unless it decides to have its own GIS team, and some do. But it does mean that the 911 authority must have a say in the accuracy and completeness of the GIS data. These here are the minimum spatial data layers that are required to support the ECRF and LVF. So we can see we've got the PSAP boundaries, of course, road center lines, emergency service boundaries, these are also called responder boundaries, and your address points. And there is a layer called a provisioning boundary that will also be needed, although most agencies haven't defined that yet. So, who is making all these rules? Well, first, I want to establish these aren't rules as much as they're recommendations, and these recommendations are made by NINA. Anybody involved with NextGen 911 needs to be familiar with NINA. NINA is the National Emergency Number Association, and it's the professional organization that, among other things, develops standards and best practices and recommendations for developing data sets that will be used in the EZINet. And NINA members with many different backgrounds contribute to writing these standards and documents. And these documents are continually being reviewed and revised as found necessary. When it comes to GIS data for NextGen 911, NINA defines shoulds as opposed to musts. In addition, states and regions and counties all manage 911 differently. And Scott touched on this a little bit. Some even establish their own standards, as he was talking about. And for example, the state of Colorado recently established a GIS subcommittee as part of their 911 advisory task force to establish oversight over GIS data for NextGen in Colorado. Ultimately, there is no mandate surrounding managing GIS data for NextGen, but there are groups, both governmental and non-governmental, that do have oversight of it. Timelines for getting your GIS data ready for NextGen can really vary, and it depends on a lot of factors. So if you've been involved in any projects like this, think about how long it takes to deploy a new CAD system, or even how long it's taking to deploy the NextGen infrastructure itself. It's not uncommon for projects like that to take 12 to 18 months. GIS data can take at least that long, if not longer, and that depends on several things. One is it literally depends on how many people are working on the data. A one-man or one-woman shop is going to take far longer to get the data in NextGen ready than a whole team of people would take. In addition, you have to consider what's been done to the data already. For example, snapping boundaries with your neighbors and cleaning up streets on those boundaries can take the longest of all out of all pre-production processes. And at the very least, it takes a long time because it involves coordinating with other teams from different areas. Something else that can take a long time is sub-addressing. This work can take many months if you haven't yet built sub-addressing into your data, whether with actual points or with attributes. It can be hard sometimes to collect all that data from different condominiums or apartment complexes or even office parks. If your center lines don't have address ranges, you're going to have to establish those as well, and that can take time too. And all of this on top of checking for spelling consistency, converting abbreviations to fully spelled out words, and other next-gen specific items. This can take months and months. People often tell me they're going to wait until the EZInet has been deployed in their area before they begin to work on their GIS data. And I think this is a huge mistake. Just having the EZInet in place doesn't mean that the system will be able to take advantage of geospatially based call routing if the GIS data isn't ready to support that. And the validation functions at the EZInet gateway won't even accept data that is less than 98% accurate for being spatially routable. If the GIS data isn't public safety grade, the 911 authority might end up with a bright, shiny new set of next generation core services, but they'll still be routing calls according to legacy or E9-1-1 standards, and that's not an improvement. So what to do next? Well, first, educate yourself and your stakeholders, and remember that the 911 authority is responsible for coordinating with the addressing authority and the GIS data providers to provision the data to the EZInet. But rarely will the 911 authority understand how GIS data is being used in NextGen or how to get it into a usable format. I encourage you, if you're working with or going to be working with a 911 authority, I encourage you to reach out to them and establish a relationship if you haven't already. You're also going to want to start learning those NINA documents. If you go to nina.org, there is a whole list of documents that NINA has published. And here's one to start with. This is my favorite one to start with. It's the NextGen 911 GIS data model. And this document outlines which data layers are required versus recommended versus optional. And it also outlines for each of those layers what fields are mandatory or conditional or optional. So I recommend printing this out to have as an easy reference right there on your desk. And piggybacking on the idea of educating yourself and your stakeholders, I encourage you to engage your stakeholders in discussions and webinars. When it's safe, meet with them face-to-face to discuss GIS and NextGen. If you are working with NextGen and 911 data, if you don't already have a GIS steering committee in your area for your PSAP region, stand one up and invite your 911 authority, invite any addressing authorities that would be contributing information to your data sets. And if you haven't done this already, call your PSAP and schedule a sit-along with them so that you can see how your GIS data is consumed for 911. That is a huge eye-opening experience when you're a GIS person not familiar with public safety. And then it also opens up great opportunities for the people in public safety to learn about GIS and how they can make the best of using the data you provide them. Lastly, share what you learn and develop and strive to understand what everyone needs. And Scott mentioned this too, and I'm sure you're realizing now that at the heart of this effort is communication and collaboration, and that is precisely what is needed to get this all off the ground. The second step in what I think would be next is to make a plan and keep it simple. DataMark, we plan, when we make a plan, the first thing that we do is to run an MSEG to a road centerline comparison, so a tabular to GIS comparison. And this will show you where you have discrepancies between your MSEG and GIS that might interfere with your location validation requirements. You'll want to check for consistency between attributes from your tabular data to your GIS, and check for spatial accuracy. For example, is your address actual or theoretical, and does your GIS reflect that, and vice versa. The next step is boundary creation and update to ensure that all your road center lines are broken at boundary changes and that address points fall in the correct boundaries. This will affect your call routing, and remember, this can take a very long time, so plan accordingly. Location, validation, normalization. This validates your address points against your road center lines to ensure that they have synchronized information. For example, you don't want your address point to say Main Street and the word street is abbreviated, but your street, your road center line segment would say Main Street with street spelled out. This won't match up in the AZINet. Comparing your alley to your address points and center lines will help you to detect missing address points. And lastly, since address and road data can change frequently, you want to develop a data maintenance plan that would ensure regular evaluation. Just think wash, rinse, and repeat. And if you're not sure how to achieve any of these steps, please feel free to reach out to me and I would be happy to point you in the right direction. After you've made a plan, it's time to assess the current state of your GIS data. And this is where you're going to want to validate your data to see how it will behave in the AZINet and find out if you meet that 98% minimum requirement. It will also give you an idea of the level of effort that's going to be necessary to get your GIS data to be public safety grade. And this will be invaluable when you seek resources from other groups and decision makers. And speaking of resources, GIS departments now with NextGen are being asked to do things they've never been asked to do before. And this is going to require additional resources, like additional staff, project funding, software and/or hardware consulting, and more. All right, and completing your next-gen data sets might require supplementing your data with data from other sources that you haven't thought of before. You don't want to reinvent the wheel. There might be local, county, state, or even federal level data sets that could provide you with a starting point. For example, if you're worried about the quality of your address points, see if the utility companies would give you, share their billing addresses with you. You would be surprised at how much data is out there that carries a potential geospatial component in it. Just keep in mind to use authoritative data sources whenever possible. And finally, and perhaps obviously, you're going to need to maintain your data. Validate it when you make changes and don't stop improving it. This is not a one and done. It's a lifetime iterative process. And because it's not one and done, start thinking about how this is going to affect your workflow. And once you get your data ready to support the ECRF and LVF, think about what you're going to have to do to maintain it. This is not the type of workflow that we've had to deal with in GIS typically. NextGen 9-1-1 requires being able to validate your data for the ECRF and LVF differently than how you might be validating your data for CAD systems if you're already supporting your PSAP. So education, planning, assessing, and gathering resources and data, continually improving your next-gen data. This will help ensure your success with NextGen 9-1-1. So I hope that this gives you a solid overview of how GIS is going to be used in next-gen systems and an overview of what you're going to need to do with your GIS data to support those systems, as well as an idea of the collaboration and communication that's required. And I want to thank you for joining me. And I think we have maybe 30 seconds for a question. I don't know if there are any questions at all. Do we have questions?
Doesn't look like it yet.
Okay, great. Well, I encourage you all to please reach out to me. If you use LinkedIn, please connect with me. I would love to carry on this next-gen GIS conversation. And thank you for having us today.
Thank you so much, Sarah. And this concludes our time. Tomorrow there is another session, so I encourage everyone to go to. And